name is Sabrina Gomez. Thank you for joining this year's Lattice Developer Conference. In this section, I'm going to go over some main factors in FPGA system cost, and we'll talk about some considerations that will help you optimize your overall cost. I'm in Lattice's product marketing organization, and one of my main focus areas is the Nexus platform of devices. I've been in the FPGA industry for over 25 years in a variety of different roles. Much of my time in product marketing roles has been managing low power, small FPGAs, where, like Nexus, low system cost is a key requirement. So here's the agenda for this session. In addition to discussing the main system cost factors in FPGA systems, we'll look at a case study from one of our partners, Oregano Systems. We'll then walk through some updates and information about the Lattice portfolio of low power small FPGAs, and then we'll dive into size, resource density, and then finally product reliability and longevity, as those also have an impact in system cost. As we'll discuss throughout the session, two main factors that are key for system cost when you're using an FPGA are power and form factor. A very broad swath of applications where FPGAs are used require low power and small size to meet their market needs. In communications, the combination of transceivers, low power consumption, and small packages are required. In computing, the high I/O density per package size as well as security are key in addition to low power. In industrial, small form factor, low power, and longevity for decades of life cycle for your product are key in those systems. In automotive, on top of all the features we talked about, they also need high temp support as well as high levels of reliability. And in consumer, obviously the small form factor is very important and the low power, but in addition, the fast time to market is a key player there, where ready IP, robustness of the solution, and reference designs and tools for faster time to market are critical for the user. So I'll go over four main system cost factors for applications that use FPGAs. There's power consumption, system control, size, and then reliability and longevity. There are several other factors depending on your system, but these are the areas where your FPGA selection is particularly important. We'll look at a case study from one of our partners, as I mentioned, Oregano Systems, to illustrate how low power consumption and system control options can help reduce overall system cost. Oregano Systems' 10 gig network interface card was implemented using multiple different kinds of FPGAs during their development phases. So that really offered very useful information in terms of comparative system cost analysis. The Oregano Systems SYN 1588 PCIe 10 gig network interface card offers PTP high accuracy connectivity required for high-speed networking. The NIC is able to power a 10 gig at line rate and on a board that does not require any additional cooling. So this was made possible by their FPGA selection. So the Certus Pro FPGA that's on there had low enough power as well as the 10 gig capability to enable them to achieve these requirements for this NIC card. And as I mentioned, they used different kinds of FPGAs from different vendors during their development cycle. So as we look at the next slide, we can see the different considerations and how they play into system cost. So let's dive into the case study. Let's see here how Oregano Systems was able to get some system cost reduction by their choices in FPGA implementation. First off, let's look at board complexity. So as you know, the number of power rails and board layers played a big part in the complexity and can drive a lot of cost on a particular board. In their choice of FPGA, Oregano Systems was able to use to 1 to 2 fewer rails. They were also able to reduce the number of board layers from 10 to 8. This is because FPGAs with lower power consumption can reduce the overall size of the power planes and also require smaller, less expensive components for the power delivery network. And this in turn reduces the overall board area as well. And with a less complex board on top of that, you have reduced manufacturing costs. FPGAs with better thermal performance can reduce the need for additional cooling, like more heat sinks or fans, and this is also quite a big system cost savings. This is really important also in specific applications like in industrial, where the requirement may call for only the fan in the main chassis and no other fans. In addition, having additional cooling equipment in the system can be costly because of just the general maintenance. Next, let's look at how engineering development cost can be lowered depending on the choices in FPGA implementation. In this study, Oregano Systems says that they can save up to 3 person days of engineering development savings based on the features and simplification offered by the FPGA they chose. This is primarily driven by the fact that they didn't have to design their own power management system. They also didn't have to worry about power sequencing requirements. This no power sequencing requirement is actually a unique feature to the Lattice Nexus platform families. In addition, the Certus Pro NX devices, which is a subfamily of the Nexus platform, is a robust, mature platform and has all the essential IP features needed to design the key required features for the system. And with that, Oregano Systems says that they basically were able to get 10 gig performance, out of the box. So that really helped their time to market, and that's another key overall cost for developers. So how does all this translate to actual dollars in savings, BOM cost savings? Well, first, if we look at power management and no need for power sequencing, based on Oregano Systems estimates, they saved up to $40 not having to have an external chip for the power management circuitry. They also said that another $10 or so was saved based on not having to have multiple discrete components that are required for a more complex power delivery network and that power sequencing requirement. So if that functionality is not integrated or simplified in the FPGA selected, then all those additional components will add cost to your BOM as well as board real estate, very valuable board real estate as well. And of course, factor in the cost of engineering time and resources and manufacturing you save due to all of these features. Now I'll share some information and updates on Lattice's small FPGA portfolio. As you hopefully know, Lattice has a broad portfolio of low power small FPGAs that are shipping in volume today. They address the needs of applications from ultra low power apps to those requiring features optimized for control and security. We offer unique feature sets, including the smallest footprint, lowest power, and optimal combinations of high I/O, different kinds of I/O, logic capacity, transceiver support, and hardened IP to meet the market requirements required in your application. Let's delve into the low power feature now. Compared to other FPGAs in a similar class that are available today, the 10 gig capable Certus Pro NX FPGAs offer up to 4 times lower power than other FPGA options in their class. Also, the Crosslink NX family also offers up to 4x lower power than similar FPGAs. And we are very excited to expand our offering and continue our leadership in the low power small FPGA space with the new Nexus 2 platform that we unveiled at this conference. Nexus 2 offers enhancements in power consumption, in performance and size. These devices are enhanced with higher fabric performance, enhanced memory interfaces, and smaller form factors. Continuing on and building upon our low power leadership, looking at Nexus 2 Certus N2 the power consumption will offer up to 2x lower power compared to other FPGAs of similar class, similar size that are available today. And as we saw in the case study, the value of low power translates to simplified power network, thermal management, power cooling. So huge value, and we continue to drive in this space with our next generation of products. Now I'd like to talk about how FPGA form factor and I/O density and integration like flash memory integration play into system cost. The number of I/O per package area is a really important factor in designs, especially space constrained applications. For example, industrial and communications that require a high number of I/O but can't afford to have a large chip or large board in that application. Applications including I/O expansion, I/O aggregation that the FPGA perform, for example, are good examples of this. Lattice Certus, Certus Pro, and the new Certus N2 family offer the most I/O in this small package area, under 10 by 10 square millimeter. So having the I/O count required in the smallest possible package really can impact and save system cost through board space savings. So let's look at this table here. We have I/O per square millimeter on the y-axis, so higher is better on the axis, and on the bottom we have package size in square millimeter, and we're looking at the smaller size packages, and you can see that you have choices in the Lattice portfolio with Certus NX, Certus Pro NX, and Certus N2 that offer a good amount, a high amount of I/O per square millimeter for those space constrained applications that need a lot of that I/O for the expansion and aggregation function. Logic density is also equally important as I/O density, so that you can house the logic and functionality required in your FPGA for your system. Starting at the bottom, today you can get an FPGA with 40K logic capacity that'll fit into a 36 millimeter square package. Going a little higher to a 100K logic density, you can achieve that density with an FPGA in a 9 by 9 millimeter square package, or 81 millimeter square. And then going up to approximately 200K logic density, you can fit that amount of logic in a 99 millimeter square package size. So based on your system's requirements, determining the most efficient package in terms of I/O density and logic density can help you optimize and reduce system cost. And you can see the choices that you make, specifically with size, can factor into that overall efficiency in your board through the FPGA choice. Another feature to look for is integration of key functions, like we talked about, power management before. Now let's look at integrated flash in terms of system cost reduction and also some additional benefit areas outside of just system cost. For system cost, of course, integration of components that would otherwise be outside, be external on the board, obviously saves board space, but it also reduces the complexity of your board design, complexity of manufacturing, and also procurement, because you have fewer silicon vendors and you have supply resiliency, or better supply resiliency often, because you have fewer vendors to work with and rely on for that supply. Besides these direct factors of system cost, integration of flash can also provide a lot of benefits, like improved boot up security versus an external FPGA. As well, in this example with the Mach X05 FPGAs, you can house multiple, up to 3 boot images for error recovery, which can improve the overall cost of ownership by increasing your uptime, allowing you to recover quickly and more efficiently. So the final couple of topics around system costs that I'd like to discuss are reliability and product longevity. Reliability is critical for avoiding your system going down unexpectedly, and if it does, being able to recover quickly and efficiently. In terms of longevity, for end systems that stay in the market for many, many years, for decades, the product life cycle and longevity of its components is crucial to avoid having to do costly updates and changes to your board and system, especially when they're out in the field. System uptime is very important in overall system cost because of the expense and effort and the time it takes to recover, as well as the services lost while the system was down, and the opportunity to offer those services. To maximize a system's uptime, many have radiation tolerance requirements. Lattice platforms, including Nexus, are designed to be resilient and have extremely low soft error rates. In this example here, the use of a barium oxide layer in our choice of 28 nanometer fully depleted SOI results in a much smaller critical active region than other options we could have taken. And that smaller critical active region results in a much, much lower probability of single event upsets. And this results, as you can see in the bottom, in an exponentially lower SER compared to other FPGA options. 16 nanometer also shrinks the transistor cross-section with a similar effect for some of our other platforms. However, choosing some of the advanced nodes, you may not have this, and the probability of single event upset increases quite a bit. So this is definitely an advantage where reliability can really help with the overall system time and maximize the uptime. So in the case that there is a single event upset, another important consideration is mitigating soft errors. In this example here, the device has a integrated hardened scrubber. The detection is performed on a frame-by-frame basis. It can be leveraged in one-shot or continuous mode, and basically it detects, flags, and optionally corrects single-bit errors. The hardened scrubber lets you benefit from this recovery, and you don't have to consume valuable logic resources in your FPGA to implement this capability. You have it hardened in the FPGA and are able to maximize the availability and uptime of this device in your system. Okay, just as reliability is super important for avoiding costly system updates and interruptions, so is product longevity. When products are EOL'd or end-of-lifed, discontinued, it forces BOM changes, board design changes, and sometimes requalification of the entire system. Your choice of FPGA should meet the lifecycle requirements of your product in the end system and in the market that you're in. Lattice FPGAs offer very long, industry-leading product life cycles by employing multiple strategies around suppliers as well as supply continuity and quality. Just as an example, from the year 2020 to the middle of this year, Lattice discontinued only 2 FPGA products, which is an extremely low number of discontinuances because of our focus on product longevity. A world-class supply chain is key in mitigating risk and making sure that there's continuity and longevity for you all, our customers. Having healthy, sufficient inventory at each stage is critical as well. Lattice is focused on leveraging globally diverse suppliers to enable innovation and innovative technologies. We use agreements, best in class, with our supply capacity, quality, and value requirements, and we drive risk mitigation through second sourcing initiatives. In summary, there are many factors to consider around system cost reduction, and today we talked about many of those around FPGA selection, including power consumption and management, component sizes, form factor, board complexity, design time, engineering time, reliability and uptime, time to market for your product, and product longevity. Lattice strives to offer a portfolio of products to enable effective system cost reductions across the vast number of applications that we play in. To learn more about this topic, you can refer to our website where you'll find this white paper that delves into the specific power topics we talked about and reducing and optimizing TCO. You can also find out more about the robust Nexus platform shipping today in volume, and on our new exciting Nexus 2 platform that we unveiled that extends our leadership in the small, low-power FPGA space. Before I wrap up, I'm going to talk through a few frequently asked questions that you may also have on your mind. So first off, what resources are available to help users take advantage of Lattice FPGA's system cost reduction features? Well, our product selector guides and product tables will help you select the combination of I/O, logic density, package size that we talked about that's so important for optimizing your system cost. There are also a variety of development boards they can use to illustrate how to optimize for power design and low system cost. In addition, there are tech notes that show you how to leverage power reduction features in our devices. For example, like the user standby mode, where you can shut down specific blocks in your design that are not being used in user mode. And then also our Radiant software includes tools from power estimators, obviously, all the way to soft error injection estimators around reliability estimations. Next frequently asked question is, how does Lattice integrate power management, enabling users to simplify their designs? Well, in the example we looked at, Lattice Certus Pro and X FPGAs implement internal circuitry and capabilities inside the FPGA to eliminate the need for the discrete components and power management that are required for power sequencing, for example, that would cost board space, design time, and BOM dollars if not otherwise integrated. The next question is, when will the Lattice Nexus 2 devices will be available? The Certus N2 FPGAs under Nexus 2 are sampling now. Next related question, will Lattice provide more small FPGA offerings in the future? So stay tuned. We'll continue to invest in this very important space for the broad range of markets and make sure that we deliver and continue our leadership around low power and small FPGA to meet the critical market needs. And the final FAQ, does Lattice provide information on how their low power products support sustainability? So as you know, the value of low power is not just reducing our cost and system cost. There's a much bigger value and impact in the world around low power. And yes, Lattice is committed to environmental sustainability with a focus on product sustainability, operational excellence, and supply chain management. We have information that also includes an estimation, an example of how our power savings makes a human impact on the world based on how much we save. Visit our environmental page at www.latticesemi.com/about/ESG. Again, that's latticesemi.com/about/ESG to learn more about that. Thank you for your time today, and please check out latticesemi.com for more information on this topic. Thank you.